Hello everyone, my name is Chetan Rawal and today I will be presenting on the topic ROC curve and AUC in machine learning. So these are the important evaluation tools that helps us measure how well the classification model distinguish between the classes. So now let's see our first point of today's why is this topic is important. In many real world applications where the accuracy is not just enough. Consider a disease detection. If only 5% of the patient have a disease, a model that predicts everyone as a healthy will have 95% accuracy, but it will be failed to detect the actual patients. This is where the AUC and ROC curve comes in. The ROC curve, which stands for the receiver operating characteristic curve, which shows the trade-off between the true positive rate and the false positive rate at the different threshold. The AUC, which stands for the area under the curve, gives the single number of summary of the model's ability at the different classes. So these are the metrics that are widely used in healthcare, finance, NLP, where the decision making requires more than just accuracy. Now, what are the ROC curve and AUC? The ROC curve, stands for the receiver operating characteristic curve, which plots a true positive rate, which is also called as the sensitivity or recall on the y-axis against the false positive rate on the x-axis, which is the calculated at the different threshold. The perfect model, which consider as a curve which reaches to the left corner, which where the true positive rate is 1 and the false positive rate is 0. The random model, which has the diagonal line which is ranging from the coordinates 0, 0 to the 1, 1, which means that the ROC curve which have the value ranging from the 0 to the 1. Now the AUC, which stands for the area under the curve, is a scalar measure of the ROC curve, which means that if the AUC is 1, then it is considered as the perfect classifier, and when the AUC is zero point 0.5, then it is considered as the random guessing classifier. On the other hand, when the AUC is less than the zero point 0.5, then it is the worse than the random. The one example of the AUC, when the AUC is 0.90, which means that the model has 95% of the chances they ranking a positive example higher than the negative one. This matrix gives us the comprehensive understanding of the model performance across all the thresholds, not just the cutoff like the zero point 0.5. So now let's see the next. How do the ROC curve and AUC works? So the first, we train our classifier and obtain the probability score instead of the hard labels. So this is the first step in the ROC working mechanism. So the ROC curve is built from the confusion matrix, which is calculated at the various threshold. So the after calculating the probability scores, we choose the threshold from 0 to the 1. So this is our the first second step. So the third step, at each threshold we calculate the confusion matrix, which contains the value of true positive, false positive, true negative and false negative. So after that we compute the true positive rate, which is the combination of the true positive divided by the true positive plus false negative. After that we calculate the false positive rate, which is the false positive divided by false positive plus true negative. After that we plot the true positive rate against the false positive rate, which helps us to obtain the ROC curve. After obtaining the ROC curve, we calculate the AUC by integrating the under the curve. So we can say that the normal workflow of the ROC building is, first we obtain the data set. After obtaining the data set, we train our model, and after training the model, we got the probability prediction, and after that probability prediction, we calculate the confusion matrix, in which will eventually help us to build the ROC curve, and after that we obtain the AUC in our model. So the here is a simple Python example which helps us to understand the how the AUC and ROC curve is obtained from the simple example, and we have plotted by using the matplotlib. This provides the both the ROC curve and the AUC value. So Also, I have here attached the one graph at the right corner, right top corner, where it shows the ROC curve, which is shown by using this yellow line, which shows the random classifier, and the value which is one, which shows the strong model, and the value which is less than the zero point 0.5 shows the weak classifier. So this is the working mechanism of the ROC and AUC. So till this presentation, we have seen the what is the ROC and AUC, and what the working mechanism of the ROC and AUC. So now let's see the what are the challenges and limitation of the ROC and AUC. Although the powerful ROC and AUC have some limitations. The first limitation is it is not ideal for the imbalanced dataset. So that they may have they may show the good result even if there is a minority class in the poorly detected. So the second one is they do not reflect the precision. So that they measure the sensitivity versus the false positive rate, but they ignores the how many predicted positives are actually corrected. So the third one is the it is a threshold independent. So this can be a drawback if we need to if we need to show the performance at the specific threshold. So these are the some limitation of the ROC, and the high AUC doesn't always mean the good performance in the real world setting. Therefore, the AUC and ROC should be used along with the precision recall curves, the F1 score, and the confusion matrix, which are the alternative of the AUC and ROC. So now to conclude the ROC and AUC, which are the critical evaluation tool in the machine learning, the ROC curve shows the performance across the threshold, and the AUC summarizes the model separately into the single number. They provide the more reliable insights than the accuracy alone, especially in the high-stake application like the healthcare, finance, cybersecurity, where the classification is more, the decision making is more reliable than the just accuracy. So in the future, research will integrate the fairness, interpretability, and the cost-aware metrics to make the evaluation even more trustworthy. So here I have attached the one summary flow of our today's presentation, which tells the overall all the today's our agenda which we have completed in this presentation. So I hope you have all understand. Thank you.